Hey everyone, welcome back to The Explainer. Today, we are taking a really massive leap. We're moving away from just basic AI experimentation, and we are going to deploy a hardened, enterprise-grade system right on your local machine. We're talking about OpenClaw. Now, if you've been following the whole agentic AI space, you already know that OpenClaw gives large language models direct operating system access so they can run these incredibly complex workflows. But raw power without any control, that's basically a recipe for disaster. So in this explainer, we're diving deep into exactly how to configure OpenClaw as a secure, highly optimized 24/7 daily driver. We're going to be looking at real code examples, dark mode terminal setups, and the precise architectural tweaks you need to make this whole system bulletproof.
So, here's a quick look at our agenda for today. We've got 4 main parts. First, installing OpenClaw on WSL2. Second, mastering multi-agent workflows. Third, maintenance and automated cleanup. And finally, security guardrails and claw guard.
All right, let's jump straight into Section 1, installing OpenClaw on WSL2.
Okay, so picture your dark mode terminal. To get the gateway daemon and the onboard wizard running locally, you literally just need these 4 sequential commands. First up, you've got to configure WSL to use systemd. If you're not familiar, systemd is just a service manager, and it allows the OpenClaw gateway to run quietly in the background as a continuous service. Once that is active, you install Node.js version 22 or higher. Then, just run a simple global npm install of OpenClaw to get the actual packages on your machine. And finally, running OpenClaw onboard launches this really great interactive wizard to hatch your bot and connect all your messaging channels. It is incredibly straightforward.
Now, what if you don't want to do that manually? Well, we can actually completely automate that entire installation process. If you're going to be deploying this multiple times, or maybe you just want a really clean recovery path, you can use these specific PowerShell scripts. The install OpenClaw.ps1 script handles all of that WSL and node setup totally automatically. And then, because let's face it, navigating into WSL every single time you want to check on your AI gets super tedious, you can use create OpenClaw shortcuts.ps1. That generates Windows desktop batch files for you. It's awesome because it bridges the gap, letting you launch the web UI or just check the gateway status right from your standard Windows desktop.
But hold on, what about the actual models powering the agent? Because running top-tier models like Claude Opus 24/7, yeah, that is going to burn through your API budget in literally a matter of days. So to save massive API costs, you can actually connect OpenClaw to local models using Allama. Here's the trick though. Since Allama natively uses your GPU way better on Windows than it does inside WSL, you want to run Allama on Windows and then route your WSL environment directly to it. You just use the command export Allama host and point it to your Windows host IP, which is usually something like 172.31.208.1 on port 11434. I'm telling you, this single line of code is an absolute game changer for your wallet.
Okay, moving right along to Section 2, mastering multi-agent workflows.
So here's the deal with single generalist agents. They are highly prone to context pollution. Basically, they get completely confused between, say, researching a deep technical topic and casually messaging your boss. The enterprise-grade solution here is to isolate tasks across 5 specialized sub-agents. You set up a writer, an editor, a researcher, a coder, and a pipeline manager. Doing it this way means your researcher can spend 10 whole minutes digging through web pages and it won't pollute your main conversation log at all. You can even set up these amazing quality gates. Like, you can have the editor agent score the writer's drafts against a strict 100-point rubric and automatically reject anything that scores under a 70. It absolutely outperforms cramming everything into one single context.
However, multi-agent setups do require some really precise configuration, especially regarding how they communicate their outputs. We've got to talk about what the community calls the deliver true leak. So, OpenClaw cron jobs have this deliver option. If you set it to true, it sends the full agent output right to your chat. The problem? That output includes the LLM's internal reasoning. As one user pointed out, which is honestly pretty hilarious but also a nightmare, they had several embarrassing moments where their WhatsApp received the agent's internal monologue, like literally texting people, "Now I'll check the calendar and then send a message," instead of just sending the clean, final summary. The fix here is absolutely vital. Always set deliver to false, and explicitly command your agent to use the message tool for output sanitization.
Next up is Section 3, maintenance and automated cleanup.
Now, if you're using automated cron jobs, you're going to run into a massive architectural quirk that we call the Dory problem.
Just like the fish, these jobs have absolutely zero memory of what happened in your main chat session. You might tell the agent today to cancel a scheduled follow-up message, right? But 2 days later, that cron job just fires anyway because it was scheduled before you canceled it. You fix this by instituting a really strict pre-flight check. You force any cron job that takes an external action to first check a specific decisions.md file. If the job sees a recent override logged in that file, it just aborts. Problem solved.
And listen, without proper maintenance routines, OpenClaw is going to suffer from gradual degradation. It just hoards the session transcripts and stale connections until things silently break. To prevent token exhaustion and total system crashes, you absolutely must deploy automated cleanup tasks. You need a script to prune session caches. If you don't, your active agents will balloon their transcripts past 50 megabytes, and that will literally paralyze your system. You've also got to rotate your daily memory logs so you're only extracting long-term lessons and implement self-healing scripts that just restart unresponsive services. Oh, and one more thing. If you're using long-running tool chains like heavy web scrapers, make sure you bump your watchdog sec timeout in the config file up to 1800. That way, the system doesn't just kill the process prematurely.
Quick pro tip for your automations here, and this is a big one. Never, ever let the LLM calculate Unix timestamps mentally. AI models are just notoriously terrible at math and calendar logic. If you let it guess, it might generate a timestamp for the past, which causes the job to fire immediately and suddenly your bot is messaging people at 3 a.m.? No way. Always force the agent to use this exact bash command, date-d, passing in your formatted time string in UTC, followed by +%s%3n. That makes the operating system calculate the precise millisecond timestamp.
All right, finally, Section 4, Security Guardrails and Claw Guard.
Because the OpenClaw agent invokes external tools, I need you to understand that the attack surface is massive. Take a look at this threat map. If your agent is out there reading a web page or summarizing an email, a simple hidden prompt injection inside that text can completely hijack the agent. It can actually trick the LLM into chaining tools together. Imagine it reading your SSH keys, compressing them, and silently sending them off to some external server. And guys, this isn't theoretical. These misconfigurations easily and quickly escalate into unauthorized remote code execution, or RCE, and website hijacking.
To mitigate these massive risks, you simply cannot rely on the default settings. You've got to apply essential hardening configurations. First things first, execute chmod 700 on your .openclaw directory. This mathematically restricts read, write, and execute permissions strictly to the owner, which hides all those plaintext API keys from anyone else on the machine. Second, make sure your gateway is strictly bound to localhost, so 127.0.0.1. That ensures it isn't accidentally exposed to your wider network. You also need to mandate token authentication to stop brute force attacks in their tracks. And finally, if you're hooking this bot up to Slack or Discord, enforce @mention requirements. You really don't want the bot ingesting and acting on every single random meme or message in a giant group chat.
Now, to truly defend against supply chain contamination, like if the agent accidentally downloads a poisoned third-party skill, and complex command injection, we turn to the FOSSA blueprint. FOSSA stands for Full Lifecycle Agent Security Architecture, and it's currently being brought to life through an awesome engineering project called Claw Guard. It uses 4 distinct layers to secure the agent, but the absolute most important one is Layer 3, the execution and response boundary. This layer actively monitors the system to correlate the agent's stated semantic intent with its actual system-level behavior. So if the LLM says, hey, I intend to summarize this text file, but the OS telemetry catches it quietly trying to initiate an external network connection, ClawGuard steps in, intercepts it, and kills the process instantly.
So I want to leave you with this final thought to really chew on. Is the allure of maximum automation actually worth the risk if you haven't taken the time to deploy enterprise-grade guardrails? Remember, the ultimate goal of tools like OpenClaw isn't just maximum automation, it's reliable automation. You got to make sure you build the guardrails, set up those isolated multi-agent workflows, and schedule your cleanups before you just let an agent loose on your operating system. Thanks so much for joining me on this explainer, and keep building smart.